How are you guys doing today? How are you guys doing? How are you, Luandile, Joshua, Overking? How are you guys doing today? How are you guys doing today? Okay, just wow. Wow, Overking. Wow. So guys, I don't want to take so much time talking. I want us to cover some things today, more especially in this topic of acids and bases. Do you guys have any questions before we start? And have you guys started studying for the exam or preparing for the exams? And how is it going so far? Are you having any challenges or maybe no? You have it all under control. So far, I'm still handling it so well. Okay, great. I'm glad to hear that, Overking. So today we are continuing with acids and bases. And today I want to start with the reactions of acids and bases that we discussed in our previous class. And we did some example regarding the acid plus metal. So you can have your acid plus metal hydroxide, which will give you salt and water. And we said that for you to get salt, it's from your cation and anion. And where do you get your cation? Your cation, you get it from your metal hydroxide or metal, or and your anion, you get it from your acid. So these are some of the types of the reactions. So you can have your acid plus metal hydroxide to give salt plus water, and you can also have your acid plus metal hydroxide, which gives you salt plus water as well. And you can also have your acid plus metal carbonate, which will give you water, salt and water. And some of the reactions that you need to know is called the hydrolysis. Yes, it's hydrolysis. This can be called the salt hydrolysis, which is a reaction that consists of ions and water. It can change the pH of the solution to acidic when it has extra H3O plus ions, or to an alkaline, which is a basic, when it has extra OH ions, when the extra N ions form. So basically what hydrolysis is that it consists of ions, but when there's too much of H3 plus, it means that that solution will be acidic. And when it has extra OH ions, it means that it will be a basic solution. In other words, a basic solution is called an alkaline. So a solution can be neutral, alkaline, or acidic. So during the reaction of a strong acid and a strong base, a neutral solution is formed. I will repeat that. A neutral solution is formed during a reaction between a strong acid and a strong base. So when you have a strong acid and a strong base, a neutral solution is formed. And when you have a weak acid that reacts with a strong base, an alkaline solution will form. So meaning this the strong base will dominate more than the weak acid. Hence the solution will be an alkaline solution. And you can have a solution can be acidic. In this case, it means that a strong acid, it reacts with a weak base. Hence, the solution that will be formed, it will be acidic. And now we spoke about indicators, and indicators is a chemical pigment that is one color in an acidic medium and another in a basic solution. As you can see today, it's very important for you guys to take note of you knowing the strong base and weak bases, so that you can know that when you have a weak acid and a strong base, you get an alkali solution. And for indicators, you need to know that, okay, this particular chemical, when it gets to a particular media, it becomes an acidic or another. And one thing we're going to discuss today is titration. But there's some definition of titration we need to know. The first one is the standard solution, which is a solution of which the exact concentration is known. So with standard solution, it means that we know the exact concentration of that particular solution. And there's something called an equivalence point. This is the point during titration where the acid or a base completely reacts completely with the base or the acid. So an equivalence point is the point during titration where the acid or a base has reacted completely with the base or with the acid. And there's an end point. This is the point during titration where the indicator changes color. So this is some of the summary of acids and base. And with titration calculation, it's important to know some of this equation. Like in this case, first you have a balanced chemical reaction or equation, and as you can see, you have acid that reacts with the base to give you salt plus water. And this A and B, it represents the balancing figure or the mole amount for this acid and base reaction equation. And remember, if you remember your stoichiometric calculations, in a balanced chemical equation, these balancing figures, they represent the moles, and you can get the mole ratio from this particular A and B. So this is an equation of titration, or we can use for titration equations. And you have Ca, which is the concentration of the acid, multiplied by the concentration of the volume of the acid, divided by the concentration of the base, multiplied by the volume of the base, equals to the number of moles of the acid divided by the number of moles of the base. So this is some of the type of the equations of titrations. So in this case, you have an acid. The key thing with titration calculation, you need to take note of which one is the base, which one is the acid, and what are you given from the equation for you to be able to calculate. Because in other cases, they will give you, for an example, the concentration of the acid, the volume of the acid, the volume of the base. You can calculate the number of moles of the acid and calculate the number of moles of the base, and you make that the subject of the formula. But the key thing in this case is to be able to identify what is your acid and what is your base. In the same way with titration, I think now we can go back to the equilibrium constant. But for acid and base, it's called the autoionization of water. And you also have the ionization of acids and bases, which is your Ka and Kb. So this is some of the theory that you need to know. I'm just summarizing everything. So you have water that reacts with water. Obviously, one will act with it as an acid and one will act as a base. Hence, you have one that gained a proton and one that lost a proton. And from this, we know that you can write your Kw, which is the autoionization of water. And this is the equation you can use for ionization of water, which is Kw. And the same with ionization of acids and bases. You have your Ka and your Kb. In this case, with the ionization of constant of acid, it is the equilibrium constant. It just has a name of, so you can call this the equilibrium constant of acid, and you can call this the equilibrium constant of the base. As you can see, you will have a chemical equation. In this case, you have an acid, water will be the base, and one will lose its proton and one will gain. And from this, you can write the equilibrium constant equation. As you can see, there is no water in the Kc. In the Ka equation, remember water is liquid and you can include that in your equilibrium constant. The same with the base. You have your base, you have water, and as you can see, there's one that gains and there's one that loses the proton. The same with the Kb or the equilibrium constant of the base. You can include water since it's liquid. So this is some of the summary of the acids and bases, and are we together so far, guys? Okay, so now let's try to do some examples and see how far we can get. How do you know what is strong and what is weak, or is it just studying? I think it's just by studying. Jade, for an example, I know that some textbooks, but it's hard to say, it's by studying or making a table for yourself. I know in the textbook that they sometimes have a question where you will have to say which one is a strong base, is this a base or this is an acid. I think it's by studying, because most of the time they expect you to already know, especially in grade 12. So I think it's by studying more. So I will encourage you to maybe have a table, or maybe next week when we do revision, we can start with that. We do a question where it want us to say if this is a strong base or an acid, so that will help you guys to identify strong acid and weak bases. For an example, HCl, which is hydrochloric acid, it's a strong acid. And you have your sulfuric acid, it's a strong acid. Your phosphoric acid, it's a strong acid. And you have your, like, it just have to know which one is a strong acid and a strong base. So I'm saying this from the top of my head, but there's like, we will do a whole table to be able to differentiate that, and especially with the base as well. Any other question, guys? Okay, let's start with this question. It says a certain anti-acid tablet contains 22 grams of baking soda, which is NaHCO3. It is used to neutralize the excess hydrochloric acid in the stomach. The balanced equation for the reaction is, you have baking soda plus HCl, which gives sodium chloride, plus water plus carbon dioxide. The hydrochloric acid in the stomach has a concentration of 1.0 mole per dm cubed. Calculate the volume of the hydrochloric acid that can be neutralized by the antacid tablet. What are we given? We're given the mass of the baking soda. We're given the concentration of HCl. We have the mass of baking soda, and we're given the concentration of HCl. And we're asked to calculate the concentration, the volume, of hydrochloric acid. So what is the first thing that you can do in this case? We can calculate from the mass, we can calculate the number of moles of baking soda, which is NaHCO3 equals to the mass divided by the molar mass. So we know the mass is given to be 22.0 gram divided by, what is the molar mass? You have sodium is 23. You have hydrogen is 1, 23 plus 1. You have carbon, which is 12 plus 16 times 3, and you will get your molar mass to be 84.01, which will give us the number of moles to be 0.26 moles. And also, before we go further, as you can see, this is a base and this is our acid. In some point we are doing a titration calculation, but in this case it wouldn't be us using the formula, but you will see what I mean. We have calculated the number of moles of the baking soda, but remember, we don't have the number of moles of hydrochloric acid. Ma'am, can you please send us the slides? I will do so. I'll definitely do that, Chloe. So we've calculated the number of moles of, so now we need the mole ratio between the baking soda and hydrochloric acid. And do you remember where to get the mole ratio, guys? Do you remember where to get the mole ratio? What is the mole ratio between the baking soda and hydrochloric acid? So with the mole ratio in this case, you get the mole ratio from the balanced equation. In this case, is the equation balanced? It is balanced. So the mole ratio, you get it from the balancing figure. As I've said from this titration, that you get the mole ratio from the balancing figure of the equation. So in this case, the mole ratio is going to be 1:1. And what does this mean? It means that the baking soda and the hydrochloric acid, they have the same number of moles. So the number of moles of HCl will be the same as the number of moles of the baking soda. And this will be equal to 0.26 mole. And now we know what the number of moles are. Are we together so far, guys? Do you understand how we got the number of moles of hydrochloric acid? Okay, great. So now we're looking for the volume of hydrochloric acid, meaning the formula we're going to use is the concentration equals to the number of moles divided by the volume. We have the number of moles, we have concentration, we can make the volume the subject of the formula, and we're going to have number of moles divided by the concentration, and we just substitute what we have. We know that the number of moles of hydrochloric acid is 0.26 0.26 divided by 1.01 mole per dm cubed, and we'll get our volume to be 0.26 dm cubed, and that's the volume of hydrochloric acid. Any questions so far, guys? Okay, let's go to the next question. This question says a learner finds some sulfuric acid solution in a bottle labeled diluted sulfuric acid. He wants to determine the concentration of the sulfuric acid solution. To do this, he decides to titrate the sulfuric acid against a standard potassium hydroxide. What is a standard solution? We said that a standard solution is the exact concentration. A standard solution, it's a solution where the exact concentration is known. So we've answered that. So we know that we have an acid which is sulfuric acid, and the learner, I thought they gave his name. The learner, he decided to titrate sulfuric acid against a standard potassium hydroxide. And we know that potassium hydroxide, it is a strong base. So the question wants us to calculate the mass of potassium hydroxide, which he must use to make 300 centimeter cubed of 0.2 mole per dm cubed of the KO solution. So this is a titration question. You see from the titration equation, you have your concentration, volume, and number of moles, but sometimes they can ask you to calculate the mass, like in this case. So what can we do first? The first thing you can do is to convert the volume into dm cubed. As you can see, it's given in centimeter cubed. So this is going, when you divide by 1,000, it's going to be 0.3 dm cubed. Now, what are we given? We're given the volume of potassium hydroxide. We're given the concentration of potassium hydroxide. And we can be able to calculate the number of moles from this equation. And we make the number of moles the subject of the formula, where you will have the concentration times the volume, and you will get your answer to be, so your concentration is 0.2 mole per dm cubed times the volume, which is 0.3 dm cubed, and the number of moles is going to be 0.06 moles. And from here you can calculate what the number of moles are. No, the mass. You can be able to calculate the mass by making the mass the subject of the formula. So you will have the mass equal to the number of moles times the molar mass, and this will give you, what is the number of moles is 0.06 times what is the molar mass of potassium hydroxide. So we know that potassium, it's 39.1 plus oxygen, which is 16, which will be 55.1, plus 1 for the hydrogen is going to be 56.11, and you will get your mass to be 3.37 grams. Are we together, guys? So far, yes, that's the answer. Okay, now let's go to the pH. I hope I still have time to explain this. C says calculate the pH of 0.2 moles dm per cubed for the potassium hydroxide solution. Assume the standard temperature. So C, we need to calculate the pH. So this is what the formula that we can use. So first thing to take note of is that potassium hydroxide, it's a strong base, which means that if it's a strong base, it can dissociate in water. And dissociating in water, it means that the concentration of the OH minus will be the same as the concentration of the solution. So which equation are we going to use? So this is the equation. We're going to have your pH equals to negative log and H plus. Or you can have, since we're dealing with a hydroxy OH ion, we can also use this. This is also a formula as well. It's called the POH equals to negative log of the OH ion, concentration of the OH ion. And we know that this both must be equal to 14. So the equation we're going to use is going to be 14 equals to the pH plus the POH. So you just add them together and they must be equal to 14 because we know the pH it ends at 14. Now we can make pH the subject of the formula because the question wants us to calculate the pH of the potassium hydroxide. So you're going to have your 14 minus POH. From this step, you need to substitute what POH is. So I'll write it in here. You'll have your pH, the equation continues, being equal to 14 minus log concentration of OH minus, and bracket. Now we are given the concentration of potassium hydroxide, and remember I said potassium hydroxide is a strong base, which means that it can dissociate in water, and the concentration of the OH is the same as the concentration of the whole solution. Hence the concentration of OH in this case is going to be 0.2, and you just substitute what the 0.2 is. So you're going to have 14 minus log 0.2 0.2. This is the concentration, but it's fine, and you will get your answer. Or this, you can just say 14 minus, when you punch negative log 0.2 in the calculator, you will get 0.69, and the pH in this case is going to be equal to 13.3. And that's how you calculate for the pH. Did you see that, guys? Or maybe it's too much to take in one go. Ma'am, why do we use log? This one is kind of ridiculous, and this is very important for you guys to know. So Chloe, we're using the pH log because this is the equation for log. So if you're studying, you will come around a lot of these equations. This is an equation of log of pH, sorry. So every time they say use calculate for pH, this is the equation that you have to use. The same as equation. This is the equation of pH. Joe, ma'am, these logs I will need to practice more. Yes, can we do more of this? I have another question, but the problem is time. But who made this? So the problem we have with us guys, it's time. Like our time is up now. But like what were they thinking? Not you guys striking because of logs. So what we can do is that because next week we are doing revision of everything we've done this term. I can start with this question because I had one more question, but I won't be able to do it because there's a next class coming. So I will say, can we end this here and start with this questions next week? Okay, I will do that. But this logs, it needs more time for you guys to understand. Next week it is. Yes. So we'll start with this topic. So I think that's it from me today, guys, and I will see you in our next lesson. Bye everyone. Plus before you go, remember that if you have any questions, please feel free to ask me and we'll work it from there. So bye everyone. I will see you guys in our next class. Have a great day further, everyone.